Okay, so let's start by looking at the pink sheet. Again, the answer for number 1 should be, I think, -6, right? Because this is telling you this function is continuous. And so our job is to figure out what its value must be at -3, right? Which must mean that this is a removable discontinuity because we could redefine it in one place and have it be continuous. So if we factor, right, we get x minus 3 times x plus 3 all over x plus 3. That's the whole, right? That's what's at -3. And so now we just need to plug -3 into what remains. So we need to know the limit at -3 of just x minus 3 because we want the limit based on the definition of continuity and the function's value to be the same. So we would appreciate it if that answer, right, was -6. Oh. All right, B is the limit as x approaches infinity, so you're zeroing in on the biggest degrees in the top and the bottom, right? And so that would be these two, right? Okay, and it doesn't matter the coefficients at all. That's how they're trying to trick you, right? Because the biggest power is in the denominator. And that's why it ends up being 0. Okay? What type of asymptote is this at y equals -1? Which way is it facing?
What?
Y equals -1 is what type of line? It's a horizontal asymptote, right? So that's why it's not D, because it's not asking about a vertical one. Okay, so you're looking, we know how to get horizontal asymptotes, right? What is it? It's not D. And it's not C. If you know anything about these functions, right, they just increase.
How do you get horizontal asymptotes?
What did we just write on our last note card?
Or regular ones?
How do we find horizontal asymptotes? Somebody tell me.
Look at the
No. No.
bottom. Said equal to 0. Right? No, that's vertical.
No.
You set the bottom equal 0.
No. That's vertical asymptote.
Maybe we don't know.
We take the limit as x approaches infinity, right?
Yes.
I don't know this.
So this function, if we take the limit as x approaches infinity, the answer is 1, right? Because the degrees match. So it's not B. That's why it must be E.
But the degrees match would be.
Cool. Well, what's the ratio of the coefficients in this one? It's -1, right? And that is the asymptote. That's the samesies.
I'm gonna cry.
Okay? Number 4 is checking realistically the same skill as number 3, right? Because it's saying, here's a horizontal asymptote. So which one of these limit statements must be true? Well, if you know that finding horizontal asymptotes, right, comes from checking these infinities out and figuring out their answers, you know it's not this one, it's not this one, and it's not that one.
Oh.
Automatically.
Yeah, just like that.
Right? And since it's y equals +7, we're going to choose B. Okay? On the back side, this is just a simple limit where you get what to happen. Of course, what is it if you plug in 3?
0.
It's not 0.
Zero. So D and E
It's indeterminate, right? So we're going to try to cancel it. Can we cancel out the denominator of x minus 3? We can if we do what else? Yes, leave a -1. Very good. So this is what remains if you cancel. When you plug 3 into that, right, you get 0. Okay. Now B is a graph that I have no idea what it looks like. Okay? You probably don't either. Okay? But let's start going through like our taxonomy of knowledge about graphs and their asymptotes, because that's the difference between these 4, right? Where do I have vertical asymptotes? Where does the denominator equal 0? Very good. So x equals 1 and x equals -1. So that means, right, that it's not C because that only has one vertical asymptote. Okay, and you really can't rule out much else than that. Okay, how do I find the horizontal asymptotes?
The limit.
Yeah, that's what we just learned.
Yeah.
So I need to take the limit of this top one, right? As x approaches infinity of absolute value of x over the absolute value of x. The plus and the minus 1 don't matter, right? What does this answer become?
1.
1, right? Okay, and then if I plug in negative infinity, does that change at all? If I find this limit, does it have a different one? No, they're both the same, right?
Yeah.
Okay, so that means I have a horizontal asymptote of positive 1, so that means I can rule out D, okay? And then I have to choose between A, B, and E. And if I know that these values are negative 1 and positive 1, can't I test points to see?
Yeah.
If I just plug in 0, which is a really good starting point, what do I get for this evaluation?
-1.
Okay, well, it's not B, right? Because when I plug in 0, I should get negative 1 down here somewhere. Okay? Okay, well, I get that for E and A. So now how do I decide between these two?
You plug in a point on the right side.
Yeah, that's the only difference between these graphs, right? So I want to know when I plug in a number bigger than 1, because that's where the asymptote is. Let's try 2. I get 2 plus 1, which is 3, divided by 2 minus 1. Well, 3 divided by 1 is 3. Okay? Remember, I know that this horizontal asymptote is 1, so it's got to be A. It can't be E. Okay?
I can see it.
All right. Real quickly through the yellow one. We got 5 more minutes.
It's a calculator one.
This is calculator, yay.
Oh,
Okay. So that means for this one, if you plug in -3 to start with, right, you get indeterminate.
Yeah.
I think so, right? So you have a couple options. You can graph it, or you can use a table of values. Okay? You can also try to do it by hand, which is what I would do, because we're good at that. Now this, right, you know, is a perfect square. So let's see if I can blow your mind here. Check this out. The square root of x plus 3 squared is what?
X plus 3. Plus or minus.
Absolute value of x plus 3, right? Which is kind of what you're saying. Okay? And so if I check -3 this way, oh, I still get an indeterminate form. But these guys will kind of cancel, right? Except that they're signed. Okay? So think about the left and the right-hand side of -3. So let's try on the left side of -3. -3.1 and -2.9. What happens to each of these values? Are they same or different?
Different.
Right? These guys will be related how? If I plug in -3.1. These will be,
They're both be really close for that.
well, one will be negative, right? So this result would be a positive answer, I think. And when we plug in this guy, we end up with a negative answer. Wait, that does not make
No,
sense.
it's negative and positive.
No, it's
It's
going to be
the
all
other
positive
way.
at the end.
Oh, because this is negative. So think about this, right?
Negative times negative.
Well, these guys cancel. So this answer is negative. And then when you plug in 2.9 on the -2.9 on the other side, you would end up with a positive result. And since these are two different signs, right, that's how we can have enough information to know that it does not exist.
You cancel. It would have been negative 0.1.
Number 2, the table gives the values of f and g at 0 based on the values given. Which does it appear that the limit as x approaches 0 is 2? So we're just analyzing right from these directions in. Does this look like there's a trend towards 2 with my fingers?
Yeah.
So I'd say yes. How about here?
Yeah.
Trending on both sides? No, this side's the worst. How about over here?
Yeah.
Does it matter that it's undefined there?
No.
No, it does not. So we're going to go with D. Okay. 3, actually, if, just to kind of save time, because I know class is ending. What?
H was right.
Yeah. If you try to plug this into your calculator, I think this is the only one that's going to give you an error. Because it's a rational power. Lastly, do we know this special limit at 0?
No.
What's the limit at 0 of specifically sine x over x? That's the one special limit you are to memorize, right? That's 1. Okay, and lastly, at how many points do these intersect? Again, I would just plug it on the calculator. Look at the graphs. It's not a very calculus-y question. If you zoom in, I think that will take out any question whether or not it's 2 times. Okay?